Hello everyone, and welcome to another session on probability and statistics. Today we will be looking at organizing and visualizing data, which is chapter 2. So let's move on. So today's learning objectives. We will be looking at the sources of data used in business. Then we will look at constructing tables and charts for numerical data, constructing tables and charts for categorical data, and the principles of properly presenting graphs. These will be the learning objectives for chapter 2. Right. Throughout this whole course module, we will be following this set of words. That is, we will first define, right? Then collect, organize, visualize, and analyze. This is the perspective in which we will be looking at probability and statistics for business in this particular angle. Now in chapter 1, we defined the variables. From chapter 2 onwards, rather in chapter 2, we will look at collecting the data, organizing the data, and visualizing the data. And from chapter 3 onwards, we will be analyzing the data. So in this DCOVA, that is, now we will be looking at the collecting part. We looked at D, that is defined in chapter 1. In chapter 2, we will be looking at the C, O, and V. C is for collecting. So why do we collect data? Now here I've given 4 examples. We can look at it from a marketing researcher's perspective, a pharmaceutical manufacturer's perspective, an operations manager's perspective, or an auditor's perspective. There are many perspectives where we can look at why someone collects data. So a marketing researcher would need data to, he or she might want to check the effectiveness of an advertisement. A pharmaceutical manufacturer might need data to check the effectiveness of some drug that is currently in use. And the best example now is in 2020, we have the COVID-19 pandemic. And these days, so many drugs are being tested in order to develop a vaccine. So there's a lot of data that is required for this. And then an operations manager, he might need data for what? He might need data to check whether the quality of a product is in accordance with the standards set by the company. An auditor, he might need data for financial transactions done within the company, whether those transactions are in line with the accounting principles. Now, if you checked the news in June 2020, there was a financial fraud occurring in Germany. The company's name is Wirecard, and now they're saying this financial fraud is very similar to what happened in the year 2000 with Enron, right? So auditors need a lot of data with regards to the financial transactions of a company and to check whether it is in line with accounting principles. So you see, different professionals, different people need data for different reasons. That is why you collect data. Okay, so we talked about collecting data, but what are the sources? Where do we get this from? So there are 2 types. One is primary source, where you yourself collect the data for your own analysis, right? So how do you collect data? Through a survey, through an experiment, or through observed data. Secondary sources is where you don't collect the data. The data has been already collected. You use that data for your analysis. That is secondary sources. So these are the 2 types of sources of data: primary sources and secondary sources. Right. So throughout this whole chapter 2, we will be looking at 4 angles. That's what I have presented here. So I wanted to ensure that the 4 aspects that we are looking at in chapter 2 is very well drafted in your minds. That is why I laid it out in this fashion. So now, from now onwards, we will be looking at the O and the V part in DCOVA. So we looked at defining variables in chapter 1, and in chapter 2, in the previous slide, we looked at collecting the data and why we collect data and what are the sources of data. Now we will be looking at organizing. If you see, the O is marked in red, organizing the data for categorical variables and numerical variables, and then visualizing the data, that is V, for categorical variables and numerical variables. So first let's have a look at organizing the data for categorical variables, so categorical data. So if you remember, there were two types of data that we talked about, categorical and numerical. Categorical variables are basically the qualitative variables. Numerical variables are basically the quantitative variables. Now we are looking at how do we organize categorical data pertaining to the categorical variable. So if you have only one categorical variable, you would use the summary table. But if you have two categorical variables, you would use something called the contingency table. Let's have a look at these. So what is a summary table? It indicates frequency, amount, or a percentage of items in your set of categories. Let's have a look at an example. So a survey was done for 1,000 banking customers. So these are your categories. What is your banking preference? The survey has asked, what is the banking preference of your customer? So the categories are ATM, internet, drive-through, likewise. And if you notice, say in the second column, you're given the percentages. And then we move into, what if you have two categorical variables? What would you do? So for that, we use something called the contingency table. Let's look at an example. So 400 invoices are drawn. Now each invoice is categorized into small amount, medium amount, and large amount. It is also categorized into whether those invoices have errors or whether it has no errors. So you see, there are two variables at play here for invoices, according to the size and according to the errors. So if I were to read this, interpret this number 100, how would I interpret it? So there are 100 medium amount invoices which have no errors. There are 5 large amount invoices which have errors. And in total, there are 400 invoices. In total, there are 65 invoices which have errors and 335 invoices which have no errors. So let's keep that to a side. Right. Now let's calculate the percentage of overall totals. What do I mean by this? So 170 divided by 400 gives me 42.5%. What does that mean? So 42.5% of the invoices are small amount invoices which have no errors. 25%, where do I get the 25% from? 100 divided by 400. 25% of the invoices are medium amount invoices which have no errors. So likewise, you can develop percentages of the overall total like this. Right, let's move on. Now that is organizing categorical data. So we organize categorical data which had one categorical variable and which had two categorical variables. Now we move into organizing numerical data pertaining to numerical variables. So we have three options: ordered arrays, frequency distributions, cumulative distributions. So what is an ordered array? It is a sequence of data in ranked order from the smallest to the largest. So that is important. It shows a range, minimum to maximum. What does it help us with? It helps us with identifying outliers. Now this is an example of an ordered array. So you have day students. It's an age of surveyed college students. There are day students and night students. The number of students are ordered in an array such that it is from smallest to largest. Smallest to largest. So that is an ordered array. Very simple. Then you have something called a frequency distribution. What is this? It is a summary table in which the data are arranged into numerically ordered classes. So you have something called these class groupings. So you have the data and you categorize them into something called class groupings. And how do you determine the width of this class grouping? Well, you consider the range, which is the difference between the highest and the lowest value, and you divide it by the preferred number of class groupings that you want. Let's have a look at an example. So you're given some data. A manufacturer of insulation randomly selects 20 winter days and records the daily high temperature. Right. So you first sort your data in ascending order from the smallest to the largest. Right? Why do we do that? Because that helps us to calculate the range. Okay, so 46 is the range. Then you would say you prefer to have 5 classes. Okay, so what is the class width then, or the class interval? The range, 46, divided by the preferred number of classes, 5. That would give you about 9.2. You round it up to 10. So how do you define your classes? You have 5 classes, and your width would be 10 to 20, 20 to 30, 30 to 40. Likewise, the width is 10. And then you compute the midpoints of each class. 10 plus 20 divided by 2, 15. 20 plus 30 divided by 2, 25. 50 plus 60 divided by 2, 55. Likewise. And this would be what your table would look like according to the data that is arranged in ascending order. So between 10 and 20, there are 3 data points. So what is your relative frequency? Well, there are 3 data points out of a total of 20 data points. Then for 100, it would give you 15% or 0.15 in relative frequency terms. We also talked about having a cumulative frequency. What does cumulative frequency mean? Very simple. So you have 3 data points initially, then you have 6 data points. So the cumulative would be 3 plus 6 is 9. In your third class, you have 5 data points. So 3 plus 6 plus 5 will give you 14 points. Likewise, you add up. And accordingly, you add up your cumulative percentage. Very simple. So why are we talking about this frequency distribution? Why do we use such a thing? Because it condenses your raw data into more useful form. Because if not, your data is just spread out. This helps you to categorize your data properly. And then it also allows for a quick visual interpretation. Now, we have the graphical representation also, but this is where we organize the data. So when you organize it, it helps to visually interpret it better rather than having data all spread out all over, right? So that is it for the organizing part of categorical data and numerical data. Now let's move into the visualizing part of categorical data and numerical data. First, let's look at visualizing categorical data. Right. So when it comes to visualizing, now remember we organized categorical data by using either a summary table if you have one variable or contingency table for 2 variables. So if you have a summary table or if you have one variable, how would you visualize this? Using a bar chart, pie chart, or Pareto chart. How do you visualize categorical data where you have 2 variables? You use a side-by-side bar chart. Let's look at a few examples. Now, this was an example we looked at where we looked at the banking preference and you're given the categories and the data pertaining to those categories. You have only one category. So you're going to use a bar chart to represent this. This is what a bar chart looks like, right? This is representing this data. Then what does pie chart look like? Something like this. A circle is broken up into slices, right? And then you have something called a Pareto chart. It is a vertical bar chart where categories are shown in descending order of frequency. Keep that in mind. The categories are shown in descending order of frequency. And a cumulative polygon is shown in the same graph, right? So what does this look like? The same example we looked before. If you see here, if you notice, it's in descending order. It's a vertical graph. And you have a cumulative polygon. So you start at 40%. Then this seems to be around 20%. You add 20 to 40 in order to get 60. Plus you add another 15 or so, close upon to 80. Plus another 15 or so, close upon to 100. And then finally it comes up to 100. So this is your cumulative polygon. And these are your vertical bar charts in descending frequency order. So if you have two categorical variables and the data pertaining to it, this was the example we looked at, where we looked at invoices, right? And for this, in order to represent this graphically, we use a side-by-side bar chart, something like this. So if you notice here, you have errors and no errors on this side, and the colors represent three types of, or in other words, three sizes of the invoices. So that is it for visualizing categorical data. Now let's have a look at visualizing numerical data. How do you visualize numerical data? So in numerical data, we organize the numerical data according to an ordered array, or we used frequency distributions and cumulative distributions. So if you're using an ordered array, how do you visualize this numerical data? Using something called stem and leaf display. If you have organized your numerical data using frequency distributions and cumulative distributions, you would represent this graphically, or you visualize this using a histogram, a polygon, or an ogive, right? So let's first look at stem and leaf display. Now what is this? Very simple. So you have data, and what you do is you sort your data into leading digits, those are the stems, and your trailing digits, those are your leaves. So what does a stem and leaf display plot do? It organizes your data into groups called the stems. Those are your leading digits. And the values within each group, which are your leaves or your trailing digits. So let's have a look at an example. So we had this particular example, and this would what a stem and leaf plot would look like. So you have your day students, your stem would be your leading digit, which should be your first digit here, and your leaf would be the trailing digit. So you have 6, 7, 7, 8, 8, 8. As you can see here, 6, 7, 7, 8, 8, 8. So if you take 3, you have 2 and 8, 2 and 8. If you take 4, you have 2. That is your day students. Similarly, for your night students also, you have a stem and leaf plot. Then, if you are visualizing your numerical data, where you have organized your numerical data into frequency distribution or cumulative distributions, you can use a histogram. What is a histogram? It's a vertical bar chart of the data in a frequency distribution, right? It's a vertical bar chart. You have to keep in mind that there are no gaps between the adjacent bars. The class boundaries or the midpoints are shown on the horizontal axis. The vertical axis either frequency, relative frequency, or percentage. So this was the example we looked at. We were given a few data points and we divided into classes, right? So a histogram of this would look like something like this, where your vertical axis is your frequency, your horizontal axis gives you your class difference, the width. Right. And the midpoints are also given here, which is given by these midpoints. Right. So moving on, you also can use a polygon. A percentage polygon is formed by having the midpoint of each class representing the data in that class, and then connecting the sequence of midpoints at their respective class percentages. So what are you doing in this polygon? You're calculating the midpoint of each class, and then you're connecting those midpoints in those respective classes. So what would a polygon look like for this particular example? So this would be your frequency polygon. You start at, if you are at 5, you start at frequency 0, then you move up to 15. That is your class midpoint is 15, and there are 3 points. If you are talking about the class midpoint being 25, there are 6. That's why it's represented by 6. If your class midpoint is 35, there are 5. So by 5. It's your frequency polygon. Then your ogive is given by a cumulative percentage. You add up these, right? So You add up the frequencies. Right. Then what if you have two sets of numerical variables? You use something called a scatter plot. What would that look like? Well, you have two variables, two numerical variables. You would represent this using a scatter plot. On your vertical axis, your cost per day, and on your horizontal axis, you have volume per day, and you just plot the data points. This is a scatter plot is used if you have two numerical data points or variables. Then you have something called a time series plot for two numerical variables. Now, time series plots are used to study patterns in the values of a numerical variable over time. So, if you take this example, your horizontal axis would be your time in years, and your vertical axis would be your other numerical variable, which is number of franchises. And accordingly, you plot the data points. Right. So, next we have a look at principles of excellent graphs. This is an important area. So we looked at organizing categorical variables. We looked at organizing numerical variables. Then we looked at visualizing categorical variables and visualizing numerical variables. So that part is done. Then when it comes to principles of excellent graphs, there are a few points that you have to keep in mind. The graph should not contain distorted data. The scale of the vertical axis should begin at 0. The graph should contain a title, likewise. So these are the main areas that I wanted to focus upon in chapter 2, because the chapter 2 focused upon organizing and visualizing data. Chapter 1 focused upon defining data, right? And this is a small chapter summary. So we discussed the sources of data used in business. We organized the categorical data. We organized numerical data. We visualized categorical data. We visualized numerical data, developed scatter plots, looked at a few examples, and displayed them, right? So thank you very much. And that is it for chapter 2. I hope you have a productive day.